Hello Year 11. This is the Combined Science Physics Higher Paper 1 Masterclass video. Make sure you're in the right room or you're listening to the right video, because if you're at the wrong tier you might miss out on something that's really specific for you. Okay, now the way this video is going to work is we're going to have different types of slides. We're going to have red slides like this one, and that's where we need to listen, we need to read, and we're finding mistakes. Okay, and then we've got green ones where you're actively reflecting and writing and you're fixing mistakes. Okay, so we're going to put up lots of different examples of exam questions where you need to spot the common error. That way you don't make those common errors when you're doing your exam. Okay, now the first thing I want to talk about is the equation sheet. You are the last year that's going to get the equation sheet. Okay, it's double-sided, it's got all the equations you need. Now, you need to take advantage of it because children in the rest of the country will do. Okay, so look at the question you're given. When it's got a calculate question, when it's got to write down the equation that links those types of equations, have your equation sheet at your side ready to use. Okay, I find it's useful to highlight or underline or circle the different quantities we're given. So in this case, we're given a question about changing gravitational potential energy, a change about mass, and gravitational field strength and height. We're given these quantities. We need to find the right equation. We need to match up those words to the right equation. And it is, of course, gravitational potential energy equals mass times gravity times by height. Okay, so use the equation sheet. Okay, go through each of the quantities you're given and find the equation that matches it. Okay, that's what you need to do. And you'll get lots of marks for that. Marks will come up where all you are doing is copying the equation from the equation sheet. Okay. So first thing I would like you to do, I've got 3 examples of those types of questions where you need to choose the right equations. The equations are on the this side of the equation sheet. I made it a little bit easier than in the exam. So they're on this side of the equation sheet. You need to pick out the right equations. Okay, so pause the video here and try and find those right equations and jot them down. Okay, hopefully you got those 3 equations now. The answers are: power is energy transfer divided by time, potential difference is current times by resistance, and charge flow is current times by time. Okay, now there's lots of equations that have power. Okay, we've got power equals potential difference times current, but I know this is the correct equation because power equals energy divided by time is the only one that has energy transfer to time and power in it. Okay, so make sure you choose the right equation. The second thing you need to do is make sure you copy it properly. Okay, write down the words power equals energy transferred divided by time. Write down P equals E divided by T. Don't change the symbols, don't change the letters, write down as it's written on the equation sheet or you might miss out on the marks. Okay, especially if you make up your own symbols. So for instance, if you did a capital C for charge, okay, you will not get the mark if you wrote down the equation for charge equals current times by time, because the examiner won't know what you're talking about. Okay, you need to use the symbols that AQA use. Okay, AQA are pretty harsh on that. Okay, next thing, we've got a calculation question. Okay, we've got air in a balloon, it's got a mass, we've got a temperature of the balloon that's decreased by 215 degrees, we've got a change in thermal energy of the air in the balloon was 860 joules. You need to calculate the specific heat capacity of the air in the balloon. You need to use the equation sheet. Now, there is a problem with this question, okay, but it's not the equation. This is the correct equation, so hopefully we can copy those equations down properly now. Okay, so pause the video, find the mistake and try and fix it. Try and find the proper heat capacity. Okay, moving on. So hopefully you noticed that they rearranged wrong. Okay, they didn't rearrange the equation correctly. Okay, now something that AQA are very harsh about is if you rearrange wrong and then you substitute, you will get no benefit of the doubt marks, you will get it wrong, you'll get no marks, you will get 0. So in this case, the student knew what equation they had to use, they knew what each of the things were, but they just made a little mistake in the rearranging and it cost them 3 marks. Okay, that's huge. That happens a few times in the paper, that's the difference in a grade. Okay, so what I advise you to always do is you write the equation, then you substitute, then we rearrange if we need to. Now, if you're worried about substitution, sometimes it can be helpful if you just draw like a line from the different quantity. So if I've got the mass here, I can do a line to the mass. So if I've got the temperature change, I can do a line to here. If I've got the energy, I can do a line here. Just helps me figure out where my numbers are going. Okay, you don't have to do that, but that's a thing. Okay, but make sure you substitute before you rearrange. Okay, moving on. Next question. We've got a hot tub. It's filled with water. It's got a pipe that connects it to a wood-burning stove of some sort. And we need to say what type of fuel is used. And we've got 4 options. We've got this tick box choice. We need to give 2 environmental effects of using wood as an energy resource. And we need to describe the change to the stores of energy of the wood, pipe and water as the water is heated. Oh, that's a big sentence. Okay, so I want you to see if they get any marks, see what you would change, see what you think is true. Okay, pause the video here. Okay, moving on. This question is pretty harsh, I think. This is a difficult question. Okay, now the first one, be aware, if it says tick 1 box, you have to tick just 1 box. If you tick 2, it will negate the marks and you won't get anything. So make sure you just tick 1 box, follow the instructions. In this case, wood is not a non-renewable biofuel. It is a renewable biofuel. Wood, it grows, it's very recently a living thing, and it's renewable. We can keep on planting lots and lots of trees. Okay, so that's not the right one. B and C, however, I think these are where it gets quite tricksy and quite difficult and quite hard. Because it says give two environmental effects of using wood as an energy resource. The fuel is eco-friendly. Sure, that's true. Okay, it does give out pollution. That's also true. But those answers are not specific enough to get the marks. Okay, you cannot get marks for saying eco-friendly. You cannot give marks for saying pollution. You've got to say why it is eco-friendly, or why, or what type of pollution it gives out. And C, even more difficult. Because it is true that the chemical energy was transferred to heat. In the wood, chemical energy is transferred to heat. In the pipe, it does have, when it gets hot, it's got lots of heat energy. Okay, this first one especially, that's true. The physics of that is correct, but we're not answering the actual question. Okay, we need to be really careful whenever we see the word change. Okay, change is the most important word in this question. Okay, because we haven't said what's happening to the energy changes. We haven't said if they've gone up or gone down or stayed the same. Okay, that's where the marks are in this question. Okay, so here we want a renewable biofuel. We want things like it causes deforestation or gives out air pollution. You could be specific. You could say it gives out carbon dioxide, okay, or other air pollutants. And then for C, the chemical store decreases. Thermal store increases of the pipe. The water, the thermal store increases. So whenever you see that word change, okay, whenever you see that word, be ready to write something's going up, something's going down, or something's staying the same. Okay, be really careful of that. There's a really good chance that this word will come up in your paper, and some of you won't remember this. Don't be that student. Be the one that remembers to write decrease, remembers to write increase, remembers to write stays the same. Okay, talk about the change of the thing. Okay, right, moving on. Next question, another calculation one. We've got a toast and some toaster. Toasters move upwards by a spring. The change in gravitational potential energy of the toast was 0.049 joules. The mass of the toast is 0.05 kilograms. Gravitational field strength is 9.8. Calculate the change in height of the toast. Okay, so here, give it a go, give it a check, see what marks you should get. Have a look at the answer. 0.02, 2 centimetres, seems a little bit small. Try and find the mistake. Pause the video here. Okay, moving on. This question didn't substitute properly. Okay, again, I think it can be quite helpful to draw a line to show where the numbers go. So here we put in height as the energy. What we want to do, we want to bring that over to here. We want to have our mass to our mass. We want to have our gravitational field strength. We don't know the height, so we can't substitute it. Okay, so the correct way of doing it, we substitute properly, we then rearrange. Now be careful of adding brackets here. Okay, be sure you're confident in using your calculator and you don't do 0.049 divided by 0.05 and then all of that times by 9.8. Remember your bid mass from maths, okay, or your bod mass. And then we have the height, it's 0.1 meters, so 10 centimeters. That sounds about sensible for a piece of toast jumping out the toaster. Okay, always at the very end, do a sanity check. Make sure your answer makes sense. Okay, right, next we have required practicals. Now, We don't know which required practical will come up, but we know one, at least one will. Okay, so we're going to go through the required practicals for paper 1 now. So the first one is on density. I'd like a little diagram, sketch down a diagram on your whiteboards or your paper on how you'd use a displacement can to find the volume of an irregular object. Try and fill in the method here, the missing bullet points. Think about what units we use for density, and then be really careful about converting centimetres cubed into metres. Okay, be really careful about that conversion. Okay, so pause the video here and give it a go. Okay, moving on. Here's my unhidden slide. So we've got a displacement can, we've got measuring cylinder. So for density, the difficulty is finding the volume of an irregular shape. With a regular shape, we can just use a ruler to measure the 3 sides and we can times it together to get the volume. But in an irregular shape, we need to find the displaced volume it makes. Now we can either use the displacement can, like on the left here, where we put the object into the displacement can and we catch any of the displaced water in a measuring cylinder. So we use that measuring cylinder to measure the volume of that displaced liquid, which is the same as the volume of the object. Or we can use a measuring cylinder on its own and we can drop the irregular object into that measuring cylinder and we can see the change in volume, and that change will be equal to the volume of the object. We use a mass balance to measure the mass of the irregular object. Now notice my language. Be really clear if you're writing methods, and this goes for all of the methods. State what you're measuring and the piece of equipment you're using to measure it. So we measure mass with a mass balance. We measure volume using a measuring cylinder. Okay. Then we've got the filled in method here. We've got mass, density and volume. Normally we would measure mass in kilograms, volume in meters cubed, and density in kilograms per meters cubed. Sometimes, however, especially if we're doing a little experiment in the lab, our objects are going to be much smaller than those. So we might have something that's only a few grams and only a few centimeters cubed. Now in that case, sometimes we would have mass in grams, volume in centimeters cubed, and our density in grams per centimeters cubed. So be careful of the units for the density. Okay, now here, okay, be really careful about that conversion of 30 centimeters cubed into meters cubed. I've done 100 to the power of 3, okay, because there's 100 centimeters in each meter, but because it's a volume unit, there are 3 different dimensions, we put that 3 in there to get our conversion. Okay, next, required practical. Next one is about energy loss through heat. So we've got a large beaker and a small beaker. We've got a thermometer to measure temperature, a stopwatch to measure time, and then we'll wrap either the small beaker or the large beaker in some sort of insulation. Okay, now depending on the investigation, you might be looking at different types of insulation, or you might be looking at different thicknesses or different layers. In this case, we're looking at different types of insulation. We've got a simple method written out here, and what you need to do is you need to say what material has the lowest thermal conductivity. How can you tell? How would you improve the experiment? What are the variables? How would you change the results? If you used ice water instead of hot water, how would that affect the graph? Maybe sketch it. And how would you say safe during this experiment? Okay, so pause the video here and jot down those things. Okay, moving on. So the material with the lowest conductivity, the lowest rate of heat transfer, is going to be material 1, the red one. Okay, it drops the slowest. Okay, it's got the lowest gradient. It takes the longest time to decrease past 60 degrees. Okay, all of those things you could say as a description of why it's got the lowest thermal conductivity. Okay, you could improve the experiment. You could use a better thermometer. So you could use one with a higher resolution. You could look at smaller changes in temperature. You could repeat it and find an average. Okay, that's always going to improve and remove random errors. You could have a you could have a better case of a lid at the top. Okay, all these things could improve your experiment. The variables, we've got the independent variable is the type of material. That's the thing you are changing. The dependent variable is the thing that you're seeing if it's affected by that independent variable. That's going to be the temperature. The control variables, and there's lots of them, is going to be things like, in this case, the material thickness, the number of layers, the starting temperature of the water, the volume of the water, the beakers you use, the piece of card, making sure that it doesn't get moist and wet when it's on top of that hot water. All those kinds of things you'd want to keep the same that could affect the experiment. Okay. If you used cold water, so ice water instead, the graph looks similar, but it would be rising instead of falling. It would be approaching room temperature. Instead of decreasing to it. Okay. Safety for this isn't a huge deal. The only thing that's really a hazard would be the hot water in the beaker. Okay, and in that case, probably it'll be enough to use insulated gloves to handle it, or make sure you've got it flat on the table when you're pouring the water in. Okay, moving on. The next one, we've got probably the most challenging of the paper 1 required practicals, calculating specific heat capacity. Now, I've got a setup here. You could replace these two pieces of equipment with a joule meter that directly measures joules, measures energy. Okay. Generally speaking, they're not as accurate as using these two pieces of equipment. So I've included this method instead. Okay. So your job, try and fill in the blanks, have a read of the method, and then try and calculate that energy transfer. I've got the equations that you would use from the equation sheet. See if you can rearrange the equation to find specific capacity. Okay. Pause the video here and give it a go. So, moving on. Here, we've got a voltmeter and ammeter. The ammeter measures current, the voltmeter measures potential difference, and we can combine these things to find the power, and then by using a stopwatch, we can calculate the energy transfer to the aluminium block. Okay, a quick way to improve the experiment would be to put insulation around that block. Okay, so reducing energy transfer into the surroundings. Okay. We use the thermometer to measure the temperature change in the block, and then we've got everything we need because we'll have mass from mass balance, change in energy from using my readings from the ammeter and the voltmeter, and the change in temperature from the thermometer. And we can substitute into my equation and we can find the specific capacity, energy divided by both mass and temperature change. The equation here we substitute into E equals V times I times by T, so the temperature difference times by the current times by the time, and in this case, okay, we've got 3,600 joules. Be careful that you change the 5 minutes into seconds. We do not work in hours, we do not work in minutes. Okay, there are 60 seconds in a minute, there are 60 minutes in an hour. So to change the 5 minutes into seconds, we times by 60. Okay, be really careful of that. There's a good chance that somewhere in your paper, there will be a conversion of minutes into seconds or hours into seconds. Okay, so be careful of that. Okay, moving on. Next practical is IV characteristics. Okay, so we've got a circuit diagram, the standard test circuit here. We've got one of the graphs, we've got the ohmic conductor, we've got filament bulb hidden and diode hidden, we've got a word hidden here, and we've got some descriptions of what these graphs tell us. Okay, so pause the video, try and draw the diagram of the graphs, try and describe what they show, and try and tell me what all the components are. And if you've got time, try and write down what they do. Okay, moving on. So in our circuit, we've got a cell. Okay, that provides potential difference. We've got an ammeter in series with our component that measures the current. We've got a voltmeter in parallel with the component that measures potential difference. And we've got a variable resistor which allows us to control the current flowing through that component. Okay, when we want a negative potential difference, all we need to do is swap the direction in the cell. Okay, we change the direction of the battery. Okay, just like you have in a remote control, if you take the battery out and you spin it around and put it back in, it will go to a negative potential difference. Okay, lots of students forget that simple thing to change the direction. For my graphs, we've got an ohmic conductor, so a resistor, that is directly proportional. Potential difference is directly proportional to current. Okay, directly proportional to current means it is a straight line that goes through the origin, goes through 0. Okay, all ohmic conductors follow this graph. It means that the resistance is constant. The filament bulb and diode are not ohmic conductors. The filament bulb has this sort of S shape that doesn't tail down, so it doesn't even go flat, but it's this sort of S shape here. Okay, and this means the resistance is changing. The resistance changes because the temperature changes. Okay, at high currents, we have an increase in temperature and the resistance gets bigger, so the gradient becomes flatter. The slope is flatter. Diode only lets current flow in one direction. When we've got a negative voltage here, we get no current flowing. Okay? So just as summary information here at the bottom. Okay, moving on. The other thing that could come up with electricity is describing what happens to the resistance of a wire and the resistors when you add them in series and in parallel. We're going to look at the resistance of a wire first. So the resistance of a wire practical, we've got a setup here where we've got a cell, we've got an ammeter, again it's going to be measuring current, and we've got a potential voltmeter measuring potential difference. We've got crocodile clips that allow us to move up and down the resistance wire, and we've got a meter ruler to measure that length. So your job, I want you to try and sketch the graph showing what happens to resistance as we increase the length, and jot down some of the other factors that would affect the resistance of a wire. You can also try and write down the job of each of the different parts that we could put into this experiment. Okay, so I pause the video here. Okay, moving on. We have pretty straightforward graph. It again is directly proportional. Okay, a straight line that goes through the origin. Okay, the longer the piece of wire, the more chance we have electrons colliding with metal ions, which will increase the resistance. Okay, so directly proportional between length and resistance. Other things that could affect the resistance: the longer the wire, the greater the resistance; the hotter the wire, the greater the resistance; and the fatter the wire, the greater the diameter, the lower the resistance. Now, this second one about the temperature is really important, because if the wire gets hot, our resistance calculated values will change. The measured values will be different. So it's important in this experiment to keep the wire at a constant temperature. Now we can do that by adding a variable resistor to our circuit and controlling the current. Okay, if we keep the current constant, the temperature of the wire should remain relatively stable. Okay, that's one way we could improve the results of this experiment. Okay, moving on. So as I said, the other part of the experiment we could look at is looking at resistance and how it changes in series and in parallel. Remember, in series, we've got one path. Now, look at this circuit. This is still a series circuit, even though we've got a junction. Okay, adding a voltmeter to a circuit doesn't change the type of circuit. It doesn't really count because it's a measurement device. Whereas in the parallel, we definitely have multiple paths. Okay? So your job, I'd like you to write down just some ideas. What's going to happen as I increase the number of resistors in series, and what would happen if I increase the number of resistors in parallel. Pause the video here. Okay, moving on. So the results should show in series that as we add resistors, the resistance increases. Okay, all of the electrons need to flow through each of the resistors we're putting in, so the total resistance is going to increase. So the total resistance is equal to the sum, so we add up all the resistances, the individual resistors, and that will be the total resistance. It's different in parallel. In parallel, the more resistors we add, the lower the total resistance. Okay? The resistance of the combined resistors is less than the sum of the individual resistors. Okay? That's because the electrons go down different paths, but they've still got the same potential difference across them. Okay? I think this is less likely to come up than the resistance of a wire practical, but there is a chance. Okay, moving on, some more exam questions. This diagram shows a bowl that's used to make ice cream. Okay, we've got an outer plastic surface, we've got an inner liquid coolant, and we've got an inner metal surface, and then the mixture that we're turning into ice cream. Okay, you need to explain why the thermal conductivities of the metal and plastic are important in the design of the bowl. Look at what we've written here, see if they get any marks, and see if you can improve it. Pause the video now. Okay, moving on. Okay, so in this case, the metal is a poor insulator. That's true. Okay, it's a good conductor of heat. Okay, it's a poor insulator, but this is asking about thermal conductivities. So the examiner doesn't care if you know that it's a good insulator or not. Use the idea of thermal conductivity in your answer. The same with plastic. Okay, otherwise you won't get the mark. So you need to describe what the thermal conductivity is of each of the materials, and then say how that affects the heat transfer. So something like the metal has a high thermal conductivity. This increases the rate of energy transfer from the ice cream. The plastic has a low thermal conductivity. This reduces the rate of energy transfer to the surroundings. Okay, so talk about what it says in the question. Read the question, in other words. Okay, next we've got a canister of air was tested to find out how pressure changed when it was used by a diver. The air was allowed to escape from the canister. The pressure of the air in the canister was recorded every 5 minutes for 80 minutes. Okay, we've got a graph. Okay, and one of the most important skills that we've got in using our graphs, okay, are generally not answered well. So be careful in reading off the graph of the numbers. Okay, we need to use the graph to estimate the atmospheric pressure. It says in bold, use figure 2. If it says use figure 2 or use table 1, if it says to do that, you will not be able to get the marks unless you use that information. Okay, then we've got the divers can safely stay underwater until the pressure of the air canister has reduced to 25% of its original value. Determine the maximum time the diver can safely stay underwater. Again, using figure 2. What would happen if the volume of air was released from the canister? Okay, so have a look at what we've done, see if they get any marks, see if you could improve it. Okay, moving on. So the first obvious mistake, they didn't use a ruler to draw their line. Okay, they didn't use a ruler to get a good line to actually their data points. Now, they were able to get the first marking point by saying what the atmospheric pressure is. So this is where it stops changing. Okay, they're able to get this, and they're able to talk about what happens when it's released from the canister. The volume is increased because it doesn't have the walls of the canister confining it anymore. But they weren't able to get this middle question. Okay, so what we need to do, we need to go horizontal and then down to get an accurate version of that time in minutes. Okay, and then we can then use it. Okay, we can then use it to find out what that pressure is. Okay, now notice we don't have to do the conversion into seconds because the answer is asking it for it in minutes. Okay, right, moving on. Why the student only get 2 marks? We've got students doing pull-ups. They've got mass of 65 kilograms. They're doing 12 chin-ups in 60 seconds. They're moving up vertically 0.4 meters. Why did they only get 2 marks? Pause the video here and see if you can spot the mistake. Okay, moving on. They didn't see that they did 12 chin-ups. Okay, they only found out the power if they'd only done a single chin-up. Okay, so be aware of these extra bits of questions. Now you can use the marks to try and guide that. If this was a 2-mark question, you'd only be expected to substitute into the right equation and then get the answer out. Okay, but because it's this 3-mark question, you're going to have to do an extra step. Okay, so you need to get these 12 marks. In fact, I think it's actually quite a harsh question for only 3 marks. I think this should be 4, but there we go. Make sure you read the question and do everything that it says. Next, why did the student only get 1 mark? Pause the video here, try and spot the mistake. Moving on. They didn't calculate their time properly. They started the conversion of hours, they times it by 60 to get 120, but they didn't change it into seconds, they only changed it into minutes. We need to change it into seconds. Okay. Next, the most challenging part of your paper are going to be the multi-step calculation questions, in my opinion. Okay. Now, they're 6 marks or 5 marks. And we know that they're multi-step because they're 5 or 6 marks. You've got to do lots of things. Okay? Now, if you don't get the right answer, there are still lots and lots and lots of marks to be gained. So, for instance, in this one, okay, if you don't do anything else, if you give a good answer, so if you use the numbers in the question and you get an answer to 2 significant figures, so you write down 123.5 and then you write down 123. Okay, sorry, 120. If you write down a 2 significant figure answer, you'll get a mark. Just writing that down. Even if the rest of your answer is completely rubbish, you'll still get the mark if you do that. There's also another mark here where we've got kilojoules. Converting this into joules could also get you a mark. So even if you weren't able to do any of the physics or any of the actual maths, you can still get marks from these questions. So don't leave them blank. Give them a go. Okay, now this question, this is one of the most challenging multi-step questions I think there is. Okay, now the benefit is there are a couple of marks that could be gained even if you get the answer wrong. And because it gives you specific heat capacity and specific latent heat of fusion, because it gives you those two things, it can help you know what the equations are, because you need to use those two equations, the specific heat capacity equation and the latent heat capacity equation. Okay, so I want you to pause the video here and see how far you can get in finding out what the mass was. Okay, pause the video now. Okay, moving on. Now, the bit of inspiration that you need to get the right answer is that the total energy, okay, is the energy for both changes. Okay, both the temperature change and the change in state. So if we use the equations here, we can add them together to get that total energy. If we don't do that step, the rest of it becomes pretty difficult. And then it's just a matter of slogging through our rearranging. Okay, now I like to take lots of steps. Okay, I like to try and make it as simple as possible before I start to rearrange. Okay, right, next. We've got another 6-mark questions. This time we've got the power of the kettle was 2.6 kilowatts. The kettle took 120 seconds to heat 0.8 kilograms of water from 18 degrees Celsius to 100 degrees Celsius. We need to calculate the specific heat capacity of water using this information. And we need to give the answer to 2 significant figures. Okay, if it didn't have this last line, there's a good chance it would only be a 5-mark question. The difference between the 5 and the 6-mark questions is you have to do an extra thing to get that extra mark to make it 6. If you just use 2 equations and you're substituting and rearranging the 2 equations, and you don't need to write units, you don't need to write significant figures, then you're just writing, you get 5 marks. Okay, the 6 mark comes from the extra steps. Okay, so give it a pause and see if you can calculate that specific capacity. Okay, so in this time we need to use the energy equals power times time equation and the specific capacity equation. Okay, and we need to substitute into energy equals power times time to get the total energy, and then by using that we can find out what this energy change is. We know what the mass is, we know what the temperature change is, we can calculate the specific capacity. Okay, and moving on. Another 6-marker, this one's 5, okay, means 2 equations. How do we know which equations to use? Now, I think sometimes, not always, but sometimes it can be really beneficial to look at what I'm trying to find out. Okay, I'm trying to find out energy, and I've got latent heat of vaporization of water. That clues me in that I almost certainly need the latent heat equation. Okay, so I might jot that down on my paper. And then I'll think, what other pieces of information am I given and what do I need? So if I know I need the latent heat capacity equation, E equals M times L, okay, I know what the latent heat is, I need to find out what the energy is, I need to know the mass. So can I use the other bits of information to find the mass? And you can using the density equation, okay? So give it a go, try and find out what that energy released is when that condensation forms in the bathroom mirror. I'll pause the video here. Okay, so moving on. So as I say, the first thing I want to do, calculate the mass. So write the end of the equation, substitute it in, do the rearranging, calculate the mass, and then use my second equation to find out what E equals ml is. Okay? Okay, moving on. That is my last question. I hope you do fantastically well. I'm sure you will have. I wish you the best of possible luck. Take your time, read the questions, okay, and use that equation sheet. That's my biggest tip. Use the equation sheet, okay? Best of luck, Year 11. I'm sure you're going to smash it.